Hi guys, it's Professor Waugh again. Now, let's learn about another double displacement reaction, and that is called your neutralization reaction. Now, this is another type of double displacement, so it's the same thing as before, where you have the AB plus CD, and you swing it, baby, and you're going to make your AD plus CB. I know that you know the general equation, and we'll always look at our wonderful solubility table. But whenever it's acid-base, neutralization reactions, these are really, really easy, because all you're going to do is look at an acid, and you're going to see the base. And you just swing it, and you'll make water, which I let you write a modified Lewis structure, which will be liquid, plus some kind of salt. A salt is a classification of compounds. So let's go through each of these to make sure you understand what you need to appreciate. First of all, if it's an acid, what is written first? Hydrogen. And what comes at the end? Aqueous. You have to have that hydrogen in front, and it balances the charge on your anion. Then let's talk about your bases. There's only two that we have to worry about in this course. Anything with that hydroxide ion, unless it's acetic acid, and also the ammonia. That's a weak base, but it's still a base. Finally, let's talk, I know you know what water is. Let's talk about this thing, salt. Whenever I say a salt, this is a classification of chemical compounds. It is any ionic compound that is not an acid, base, or oxide. So when I say oxide, what am I referring to? You know, MgO. That's magnesium oxide, lithium oxide, barium oxide. That is not considered an acid, a base, and definitely not water. All right? Okay, guys, so now let's do some examples of our acid-base neutralization reactions. So, let's get a little lithium hydroxide, which I wouldn't want to play with in the laboratory. But let's react that with something simple like hydrochloric acid. So again, this is the ABCD, swing it baby kind of mechanism. So identify your A. Keep that polyatomic ion together. Don't you break it up. That's your B. Here is your C. And there's your D, the chloride ion. Now we're going to swing it, baby. And same as we did before, with all of our double displacement reactions, just say the names. Lithium chloride. So you can just write that out, because you know that's a +1, -1. You don't know the state yet until you reach your solubility table. Plus you have this H and the OH. So you can just write it like that, and you know that's water. Whenever you have an H plus aqueous in solution with an OH minus aqueous, they always come together to make water. It's lower energy. That's called life. So let's look at the solubility table, and you can see group 1A will always be aqueous. And then you can look and see you're already balanced. Isn't that easy? Check. Now, guys, let's do a little bit more complicated reaction. So let's take a little phosphoric acid, and let's put that inside of a container with some barium hydroxide, aqueous. So again, what I want you to do, and in the phosphoric acid, I'll tell you, we'll break down into several steps, but right now, we'll just do basic chemistry. So your phosphoric acid as a whole looks like so. And your barium hydroxide, as you know, barium's a 2+, the hydroxide's a -1. So I need 2 of those. And I told you it was aqueous. Again, identify your ions. So this is your A, just the hydrogen. Don't take that little 3. Okay? You can only take the subscript if there's a polyatomic ion. Here is C, just your barium ion, and the hydroxide ion is your D. Now let's swing it, baby. Woo! Okay? Now once you swing it, you just say the name of what you're going to make on the product side and write the formulas correctly. All right, so I got HOH, and what do we know that's always going to be? Water. So here we go, H-OH, liquid. We're not at elevated temperatures, plus we have a barium phosphate. And you got to look at that solubility table on this one. So we can balance it real quick because you're smart like that. When you look at that hydrogen, I don't want to start there. I really want to start with this phosphate because that'll never start with your hydrogen. As I taught you, you always do your polys first, then anything that's not hydrogen and oxygen, then your hydrogen, and then the oxygen. Look at the previous YouTube videos. So when you look at your phosphate, 1 phosphate on the reactant side, 2 on the product side. So I immediately put a 2 here. I cannot put it behind that because then you're playing God. And if you are God, I need to talk to you. The next thing, let's talk about this barium ion. I have 3 on the product side. I better put a big 3 there to balance that off. Then, oh my goodness, how many hydrogens do I have? 6. How many do I have over here for hydroxide? 6. We've checked. We have not wrecked.